All right, welcome to our discussion on Java interfaces. This is an important part of Java, and we'll get right into it. So, interface challenge 1. Start a new Java project called Shapes. In Shapes, create a Java interface called Printable. In Printable, create a method header called print with no return and no parameter. Eclipse will create an interface just like it will create a class. And then search for Java interfaces via Google to find out any other information that you need. At this point, you can pause the video and complete the challenge. You'll see my solution on the other side. All right, my solution. I have an empty shapes project. Find new, and I pick interface. Create a printable, name printable. Notice that the interface is very similar in structure to the class, except for the keyword interface. Here I am adding my method header. And we're finishing it. Instead of with a method body, begin curly brace, end curly brace, we end it with a semicolon. We have no implementation at this level. Okay, let's review it. We started a new Java project called Shapes. In Shapes, we created an interface called Printable. In Printable, we created a method header called print, and with no return and no parameter type. An interface in Java is a blueprint of a class. It has abstract methods. The use of the method is understood, but the implementation is not known yet. Therefore, it's an abstract method. It doesn't have a method body. It makes sense. The implementation is not known, so we end the interface method with a semicolon. It can never be used to create an object. Object requires concrete classes that have method bodies. So interfaces turn out to be very important, but they're never objects on their own. Instead, they become parts of other objects. Interface challenge 2. Create a public class circle that implements printable with a simple implementation, print a circle. Create a second class rectangle that also implements printable with a simple implementation, print a rectangle. At this point, pause and complete the challenge, and I'll join you on the other side. Okay. Here I am. I'm going to create a new class. Called circle. And I'll begin by implementing the printable interface. Notice the keyword implements. Correct my spelling error. Now there's another error. And it's because we promised to implement printable and we haven't done it yet. Add unimplemented methods, and we see that we've added a print with a method body here. So we've fulfilled the interface. We haven't written code for it yet, which we'll do next, but as far as the compiler is concerned, we've implemented the interface. You can also think of an interface as a promise. I promise, when I implement printable, that I will have a print method that looks identical, that is the same method header as the one that was declared in the interface that we used. So it doesn't have parameters, it doesn't have a return type, it's identical to what's in printable. We'll create our second required class, that is rectangle. And it's very similar. And in this one, I got a little bit hung up on here, and I discovered that I needed to save all the files. Notice there's unsaved files with the asterisks by the left-hand side of the file name. So Control-Shift-S is what I did, and then now we have the add unimplemented methods available to us. Once all the files were saved, you may encounter that as well. And then a simple implementation of the print method. Okay. So Rectangle has promised to implement the interface, and it did. And now we have Interface Challenge 3. In Shapes, create a Java interface called Drawable, so a second interface. In Drawable, create a method called header called Draw, with no return and no parameters. Modify the class Rectangle so that it implements, it should say Drawable there, as well as printable. So we have our interface Drawable with the method signature Draw. No return type, no parameters. And Rectangle now implements both printable and drawable. Notice the syntax is very simple there. It's a comma-separated list. So you can implement as many interfaces as you need. 6, 7, 8 interfaces. Remembering that each interface is a unique promise to implement the methods that are declared as abstract methods in the interfaces. So here I have a simple print method, print a rectangle, that was created before, and I've added now the draw method that actually draws a rectangle, or prints drawing a rectangle. The circle remains unchanged, just implementing the printable method with the print. So we have print, we have drawable, and we have two concrete classes, a circle that is printable, and a rectangle that is both printable and drawable. So diagrammically, we have a circle that is drawable, and then a rectangle that is drawable, but also printable. So there's an is-a relationship that goes up the hierarchy. And we'll talk more about that. A circle is a drawable. A rectangle is a drawable, but a rectangle is also a printable. Circle and rectangle are siblings, but they are not type compatible. So a circle is a drawable, a rectangle is a drawable or and is a printable, but they don't have that type of relationship with each other. The is-a goes only up the inheritance hierarchy and not sideways across siblings.